Just switching the screen.
Sure.
And then we have how much time? 15, 20 minutes?
Yeah, 20 minutes, that's right.
Excellent. And do we do questions?
So, yep, we will open up for questions after your session as well, no problem.
Okay, excellent. Then I just click on share screen and start. Yeah.
Yes, you can start, Carsten. We can see the presentation.
Yes, my name is Carsten Stoecker. I'm CEO of Spherity. And at Spherity, we are developing digital identity software solutions. So our primarily focus is to develop software solution for what we call in Germany for Industry 4.0, or what's also being called the fourth industrial revolution. And I would like to explain a bit what this means and how can we dare as a startup to really go in this, this kind of identity game, because this identity is super competitive. And of course, as a startup, when you would like to develop identity for the fourth industrial revolution, then you have to do identity for humans, for machines, for enterprises, for things. And this sounds insane, but I would like to share how we address this. And it's so it's a fantastic opportunity domain being there. Yeah, so Spherity, at Spherity, of course, we are all aware, not only at Spherity, you're also aware, so that the internet, the number of machines, the number of things is growing exponentially. I think when the internet started, there were a couple of 100 million domains and enterprise systems that were on the internet. And then with all the smartphones, suddenly we had all the humans, 4 billion humans in 2005. And now slowly and surely the Internet of Things is being adopted, which means we had about 7 billion things in 2010. And now in just 2 weeks, the estimate is that we have 40 billion connected things on the internet. This is still exponential growth of the number of IoT devices, software agents, Alexas, virtual private assistants. So it's really growing exponentially. But what's not only growing exponentially, so it's not, this is Alexa in the background. So what's not only growing exponentially is not only the number of devices, it's also the number of transactions, the number of connections among people and things, and the sheer amount of information, which is also exploding. And as a business that's used to work in linear value chains that have been established for dozens of years already, which means I'm a customer as a supplier, so we know each other for 20 years, so we put a lot of quality controls on top of it, from Sarbanes-Oxley to other quality controls to TÜV to quality inspectors, and then I can start to trust my counterparty. But when now everything is fully connected in a 5G fully connected world, then it's more difficult to especially for business. So how can I trust the sources, so where the information are coming from, and how can I trust the integrity of the information I get? And that's the problem that we are addressing at Spherity. I think I would like kind of to do a quick reality check. You're all aware, I assume you're all aware of this, because in the internet, nobody knows if you're a doc, if you're a real SAP employee that's still employed by SAP, or if you're an authentic OEM machine, such as a BMW, a Bosch machine, a General Electric machine. I just don't know. I get some data, but are the data being generated by a malicious actor, by a bot, to simulate there's a fleet of BMWs and try to sell the data on a marketplace, or try to attack a driver assistant or autonomous driving backend system. So we just don't know if the data are authentic, coming from calibrated real BMWs, and so on. Same story for product suppliers. And this is where we come in at Spherity. So basically, when we look in the human world, so we all have our briefcase, our wallet, with all the physical identity cards and driver license. And then, as one of the first steps, people started to experiment what we call self-sovereign identity. They're trying to generate out of entropy, out of randomness, a public-private key pair. use the public part of the key to generate an identifier, and then go to a couple of issuers such as know your customer, KYC credential provider, or such a university, and ask them, hey, university, please give me digital credentials that have a university diploma for my digital identifier, and so I can reuse it with every employer in the future in a fully digitized process for super fast onboarding. So in Germany, the entire automotive industry is looking into this, especially for mobility, because when I have fully digitized credentials, a driver license, ability to pay, some bank credentials, and my identity credentials, then it can be seamlessly onboarded. I can be instantly onboarded to be part of mobility service. And what we do at Sverity, so we go beyond, let's say, people having kind of digital identity on their smartphones. So we primarily bring the same decentralized identity solutions to cloud, fully scalable, fully machine automated verification and payment processes. And then I can request credentials from multiple sources, verify them, establish trust with the counterparty. So that's what we do. So our product that we are developing has 4 features. One is the verifiable identity itself, with all the decentralized identifier stuff. Then we have what we call credential-based trust. So let's say there is a machine, a weather station, and I would like to consume the data, but I still don't know is it fake weather station or real weather station. And what I can do when I would like to consume the data, I ask for the credential of the weather station, which means to who owns it, who produced it, did someone calibrate it, is there kind of reputation credentials about this. And when I get all these credentials, I can machine readable fully verify them and put some risk metrics on top of it. And then I can basically develop a risk score for my counterparty. So in this case, the weather station, but it can be also an enterprise, a car, an algorithm, whatever it is. And then I can think about, do I trust the source? And do I trust the integrity of the data? Then I can get a risk score. And together with the risk score, I can feed these data into decision making of my digital software to make sure, yeah, I'm not attacked by a malicious actor or by a hacker or whatever. The next, what could also be done is a lot about access control, because when I know it's an SAP employee or Lufthansa pilot with a license to fly big airplanes and background security check, and if I have these credentials, these 3 types, I can basically open the door at the airport to give the Lufthansa pilots access to critical security-related parts of the airport. And that's another example to use the same stuff, credential-based trust, and then have some access transactions, to do something or to trigger something or to do business transaction. So of course, when I then know my counterparty, this is what we call it's DocuSign on steroids. So DocuSign is kind of crap, because I basically store the IP address of someone who signs a business document, and then the counterparty puts a little bit of a signature with a mouse in the document. But when I've verified the digital credentials, I get the cryptographic signatures. So I sign it, I get it countersigned with a cryptographic signature from my business party. That is DocuSign on a much higher maturity level. And that's what we call DocuSign on steroids, because it couldn't be only done for humans, it could be done for all the machines. And we think it's very important to do business in the internet. The 4th feature is provenance of data. So where do I know the data coming from authentic BMW? We're fed in an algorithm. I get some driving event labels out of it. I use driving event labels for risk propositions in insurance industry, for driver assistance systems, autonomous driving backends, or even for, let's say, business decisions or control decisions in the mobility system. But then I clearly have to know, is the BMW, the data authentically coming from the BMW? Have someone tampered with it? Was the algorithm being benchmarked? Can I trust the algorithm? And when I have these provenance data, I can put a risk metric on top of the having event labels, and then I can consume them, because otherwise I couldn't be sure it's a hacker or not. And this is where Sverity comes in. So I would like to share a bit the technologies that we are using, because I mentioned as a startup, so it's a bit of insane. It's like boil the ocean. And if you think about it, identity, so we did bottom-up market analysis. And so in 2023, the global GDP is more than 100 billion US dollar, a bit more. And we did a bottom-up calculation, but let's also do it top-down. So when we assume we spend 1% of the GDP for all kind of identity and security related services, from provenance of data to supply chain tracking, identity for people, identity and security for IoT devices, 1% is not too much. It's kind of realistic. So then the entire market that we're addressing here for identity and security in the fourth industrial revolution is about 1 trillion in 2030, which is super big. Of course, for a startup, it's a bit of insane to address it. However, having said this, so we are using technologies developed by the W3C consortium, the World Wide Web Consortium. It's developed by a couple of startups. It's developed by big corporates such as Microsoft, HTC, PS1, but it's also developed by the inventors of the internet. So Tim Berners-Lee, you all know him, Christopher Allen. Christopher Allen did the S in HTTPS, he did the S for this. Couple of other veterans from the internet, and they all said identity was screwed up. You remember the dog picture I showed to you? Now we have to find a better technology. We have full control about my identity, I have self-sovereign control about my data, and there are more than 1,000 man-years of research and development work already invested in the standards, and we basically pick up these standards because they are meant to have been developed to exactly solve this problem. Solves this problem when there's an unknown actor in the internet. I have no clue who this is, but I can request credentials, verify them, and then I can establish trust with the unknown actor. Right. So we are using the W3C so-called decentralized identifiers, and we basically apply them for all kinds of entities, humans, enterprises, objects, machines, data, transactions. So we combine this with secure key management because this is all based on public key cryptography, and the Achilles heels of security, whatever we do in the internet until we have quantum key distribution and some other fancy technologies, but let's say for the next couple of years is surely built upon public key cryptography. And for that reason, secure key management is part of our proposition. So in addition, and I will explain it to you what it did is, in a verifiable credential, we use so-called verifiable credentials to digitize in a very effective way assertions or certificates about anything. And this is not super fancy. It's basically intelligent, comprehensive, very well thought through further development of digital signatures now being standardized. And we think these are the key technologies to establish trust. But this is not enough because we have to do a bit of access control, peer-to-peer transaction, interoperability. And then we combine it with a semantic model because I don't know how do I capture data, how do I present them, how do I interpret them, how do I capture data from an identity card? Is it string? Is the UTC time? Is it a Boolean? Whatever it is. And for that reason, semantics is also important, and that's what we basically integrate to provide digital identity. Some other people call it digital identity wallets, digital twins, digital product memories, digital product records, whatever it is, it's all the same. And so we are basically combining these technologies. Having said this, W3C, the DITs, you can say it's a URL for an individual. It's heavily pushed forward as a standard to generate bottom-up identifiers. It's a simple syntax. It starts with the DID, a method. The value of it's when you can anchor the decentralized identifier on an immutable ledger, but having all, let's say, data not connected on the ledger, fully off-chain in terms of privacy. But when it's being anchored on a ledger with the identifier is being kind of derived from a public key, then it's fantastic because I can print this identifier. I can put my identifier in my smartphone wallet, but I can also print it on a manufactured object, on a machine, integrated machine. And then, I basically can interact with this. As every unknown actor, I take the identifier, I know, it's a DIT. I have to go to Ethereum, Bitcoin, Sovereign, whatever the method is. I request the identifier, and then I get back a so-called DIT document. And that's fantastic because I can do this without relying on a centralized system, on a GE Predict system, on a Bosch IoT platform, on an SAP Leonardo IoT platform, you name it. Basically, I don't need to be onboarded to these ecosystems. I only take the DIT, go to retrieve the DIT document from a public ledger, get a set of keys. And this is important because you might want to rotate your keys, you might want to add more signing keys. So it's basically bootstrapping the identifier so that any other persons can verify, okay, which public keys are connected to this. That's one big proposition. The other is you can also put a so-called service endpoint into this. And that's what a lot of German engineering companies are currently exploring as well. Put a timestamp, a signature, but it's primarily about bootstrapping the entropy, the keys, and then linking a service endpoint, which means I have my serial number, I go to the ledger, retrieve the service endpoint, and then suddenly I can interact with it. That's pretty intelligent because today's serial numbers are hidden in SAP systems behind a firewall. There's no way how can I get to the serial number and get lifecycle information about an object or a machine. But with a service endpoint, this is possible. And that's what people do. So think about a car, a vehicle with a vehicle identity in a decentralized format. I might have registered it in a car sharing marketplace. I discover it there. Then I retrieve the DIT document. I go to the service endpoint, and suddenly I can interact with an off-chain business logic, such as car sharing. I can even buy data from the car and feed it in a marketplace, whatever I'd like to do. But before I interact with the business logic, I just request credentials from the car, because behind the service endpoint, the credentials store, and then I can request credential. So what is the birth certificate, who's the manufacturer, what's the vehicle title, what's the insurance title. And when I have this data, I can trust the car, and then I can start doing some business with it outside the security parameter of the vehicle. And that's also pretty interesting, because if you think about all these autonomous car sharing something propositions, and you have to interact with the car and the IT in the car, it's still a security risk, but doing it outside, it's also from a security perspective good. And when you think fleet, putting optimization algorithm on top of it, then you come up with entirely fantastic new propositions. And that's, by the way, what we have done with Digilabs and with Swap and with VJ, looking into fleets of autonomous cars that are shared and electric. So giving a decentralized identity, putting algorithms on top of it, and then optimizing entire fleets. It was very nice. Yeah. The other technology, but I might need to speed up a bit, it's so-called verifiable credentials, the further development of digital signatures. Yeah, I think that's the basic idea. So there's an issuer. Issuer can be an authority such as the TÜV, or can be the government, the Indian government, the US government, the German government. For example, issuing credential about the vehicle title. Then the vehicle is the identity subject. I, as an owner, are the identity holder. Basically, I get the vehicle title stored in the car wallet or in my wallet. I can present it to any inspector. An inspector can be even an insurance company, but can be also a person who wants to do car sharing. And then the person can validate, okay, it's an authentic car, insurance, birth certificate, blah, 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 and that's fine. And what's really fantastic is the inspector does need to be onboarded to any platform, to any ecosystem. The inspector only needs to understand the W3C standards, and via this, it can verify the entire life cycle of the car, and it's a very powerful proposition, especially in the fourth industrial revolution, when we have dynamically defined value chains from manufacturing to mobility, and there are unknown new actors that would like to interact with each other. Yes, then I need such a technology that's not bond or locked into to few specific platforms that don't communicate and interact with each other. And this is being kind of enabled by this little combination of the DIDs and the verifiable credentials, that any unknown inspector in a FOSNA solution can verify the claims. So I'm personally very passionate about, there are also a couple of use cases. Car people are looking into usage-based insurance, real-time vehicle value, predictive maintenance, car pass, vehicle registry, data marketplaces, whatever it is. A lot of propositions they distinguish between life cycle data, which are more static, but also telematics data, the IoT data coming out of the car, that have full data attestation of the data, and then a provenance audit trail where the data coming from. Very nice. But so what I'm personally very passionate about is the circular economy, because think about this, you get what you measure. If you don't measure provenance of objects, have we designed out the waste? Is it really sustainable? How can we use it? What ingredients are in the product, in the object in the circular economy? If you don't have full audit trails, so people try to sneak in, let's say, fake products, unsustainable products with big carbon footprints in the supply chain, and this is what humanity cannot afford at all. So because right now we are programmed for an exponential disaster, so we have to kind of to switch the gears, fully sustainable, fully renewable, fully circular with reuse, designing out the waste. But if you don't measure it, so people will kind of tamper with the system. That's what you cannot afford. And circular economy, it's basically as a crown jewel use case when any unknown actor needs to go full back to birth traceability, verify provenance, supply chain transparency data about the object, and then you need such a technology that allows this, and then you put your algorithm on top of it to optimize the entire circular value chains. That's what we do at Spherity, and the name Spherity, I would like to conclude with this. It's coming from the fourth industrial revolution, which is a fusion of technology. It's not only one, it's a fusion of technologies, bridging the physical spheres of objects, machines, the biological spheres, human enterprises, and the digital spheres, algorithms, digital assets. And then that's kind of combination of sphere and identities named Spherity. And that's our vision, and that's what we do at Spherity. Yeah, and thank you for your attention. It's a pleasure being with you today.
Thank you so much, Carsten. Just one quick question. So you briefly touched upon, I guess, faves. So if you can just give a hint of how there could be the correlation of IoT with machine learning, AI, and blockchain in that particular concept, I think it would be really good. If you can just give like a quick high-level conceptualization introduction to that with regards to faves.
Yeah. So faves is a concept which is called fleet, with the F, of autonomous vehicles that are electric and shared. So this is faves. In a faves world, you basically have your fleet of autonomous cars. You don't have car ownership anymore. And in this world, we need about 7% of the cars compared to today, so we can get rid of all the kind of the garbage on our streets. And when you have the faves, you have to provide identity to the cars. You have to connect identity to IoT. That's a bridge between identity and IoT. But of course, in the faves, you have a lot of algorithms running locally in a car. And you have a lot of algorithms running on top of it in the cloud, running on top of the entire fleet, doing optimization. For example, redeploying cars from an area with low demand to an area of high demand, optimizing entire mobility patterns, because we have peak demand when we have the rush hour in the morning, when we have the rush hour in the afternoon. That's all to be taken into account by algorithms when it's being electric. We also need to think about algorithms and the AI piece in terms of how to optimize the charging of the cars, how to optimize the usage of the cars and the occupation and the maintenance. And yeah, there we need a lot of algorithms. What's also interesting when I have the car which is autonomous in terms of driving, and I can also give an identity, so it can basically start to do business with, because it can authenticate itself, it can make contracts by cryptographic signing, and it can, when we have, let's say, also a payment wallet, can receive payments for services it's providing and pay for service it's consuming. And for that reason, that's a very interesting concept in terms of the self-owned car. But so I personally believe more in fleets of cars and then having autonomous capabilities at the edge in the car to make local business transactions and optimize them to which region to go, what kind of transaction to do, which route to take. But also on a fleet perspective, because in the end you have to optimize the entire fleet, not only from a commercial perspective and technical perspective, but also from a demand perspective and also from a mobility situation perspective. And that's where a lot of algorithms comes in, a lot of IoT, a lot of identity and cloud and edge. It's a very nice story about fusion of technologies, I would say. Yeah.
Right. I think thank you so much, Carsten. That was really insightful. And I think on behalf of the team here, and of course on behalf of Vijay as well, I would like to thank you for taking time out for a Saturday and doing this for us. Thank you so much. And I will be sharing the presentation, of course, to the group, and also I will connect back with you, I think, once we are done with the event today. Okay.
Excellent. So thanks for having me, and I'm very much looking forward to do some follow-up activities with you guys. Yeah, it's great to be in touch and connected. Enjoy the rest of your conference. Take care.
Thank you, Carsten. Thank you. Bye now. Have a good weekend.
Yeah,
bye.
Bye-bye.